Hi everyone, welcome to Module 3, which is working with fMRI data. This is the start of Section 2, called Intro to fMRI Data, and we're going to be answering the question, what is fMRI data? So for this first lesson, this is going to be a pretty short video. Most of it is going to be the Google Colab that I'll talk about later. But like I said, we're going to be talking about what is fMRI data, and then in future lessons we'll be going into fMRI dataset pre-processing and visualizing fMRI data. So since this section is really data heavy, it's going to be a little bit of a different format. It's going to be mostly Google Colab, so kind of similar to Jupyter Notebook if you used that before, and fewer videos. So this is going to be one of 2 videos for this section. And what we want to talk about in this video is, first of all, kind of a little review of what we talked about before. So here, remember that fMRI measures activity of the brain by tracking blood oxygenation levels in the functional areas of the brain, and also that the functional activity in the brain is measured by something called the BOLD signal, which is the blood oxygenation level dependent signal. And some key questions we want to answer are, what does fMRI data look like? How do we load fMRI data, and what are some basic manipulations of fMRI data we can do? And most of these key questions are going to be answered by going through the Google Colabs on your own, which are formatted in a way that, like, if you read the descriptions before running the cells, you should have a pretty good idea of what's going on. But just in this video, I'm going to do a little bit of an overview, a little bit of a preview of what you're going to be seeing in that actual interactive assignment. So first of all, what is fMRI data? Remember that it's the BOLD signal, which measures the ratio of oxygenated and deoxygenated blood throughout the brain. fMRI data is also represented visually in something called voxels, which are volumetric pixels, if you remember. And these show the aggregate activity of a group of neurons. So it gives us the spatial resolution of fMRI, and that's why fMRI has such good spatial resolution, because these voxels give us the 3D coordinates x, y, z in the spatial plane. Another thing, though, is that it gives us a time coordinate. It doesn't have great temporal resolution, but the data has a 4th dimension or coordinate that is time, because the changes in these voxels are tracked over time. So actually fMRI data is usually a 4D data array with change over space and time. So fMRI data is commonly in a file format called DICOM, which stands for Digital Imaging Communications in Medicine. And DICOM files are most commonly used for any sort of medical scan images, so anything from ultrasound to MRI or fMRI. And these may actually contain patient identification information. However, what we're going to be using for this lesson is something called the NIFTI file format. This is another format that fMRI data can be in, either NIFTI 1 or NIFTI 2. And basically it contains coordinate definitions relating the voxel index to the spatial location. So it's kind of like mapping to the XYZ spatial plane that we're used to. And it's a standardized way to store basically vector value data sets. So once again, this has to do with like the spatial locations over multidimensional domains. And another thing is that it doesn't actually directly store fMRI data. The NIFTI file contains information about the fMRI data stored in the file, which can be accessed using attributes or by looking at something called the header of the image, which we'll be looking more into in this lesson assignment. So you'll get a chance to kind of play around with accessing attributes and looking at the header. So in terms of loading fMRI data, there's something called the NIBabble package, which provides read-write access to common neuroimaging file formats, including the NIFTI file format that we're going to be using, and also DICOM that I mentioned before. So in this package, we're going to be, in this lesson, we're going to be using this package by looking at and manipulating an empty example NIFTI instance from the NIBabble.testing package. So this NIBabble package includes some kind of like blank testing sample data you can use to just play around with different types of arrays and different forms of like data manipulation, just kind of for your own testing. So we're going to be starting with that. So don't be alarmed if the arrays that you get in lesson 1 are all just like zeros. It's supposed to be an empty example. So here's some example code for loading the NIFTI data. And as you can see, all you have to do is import the package, import NIBabble, and then from the package, the testing package I mentioned before, import a data path, which then you can use to NIBabble.load the image path, and you'll get the image. So this is, in case you aren't familiar with Python, this is in Python, and for the most part, it's pretty similar to English. I think it's pretty intuitive, like you're importing a package, and then from a package, you're importing another thing, and then you're loading that path. So this is kind of something you'll get some hands-on experience with soon, but don't be worried if you aren't familiar with it, because for the most part, it'll just be running the cells. So, and then if you are familiar with this stuff, feel free to play around with different parts of this package, look it up on the official website, and then feel free to kind of figure out other ways to manipulate this data. And then kind of something I wanted to review again, because it's really important, is the data format. So remember that there are 4 dimensions typically in fMRI data. So there's X, Y, Z, which is X and Y give you the kind of area of the brain slice, and then Z gives you the number of horizontal slices. So remember, when you're taking fMRI images, a lot of the times you're going to be looking at actual brain slices. And so in order to move through those slices, you've got each area plane, X and Y, and then you have many, many, many of those slices. So the Z dimension gives you like the number of the horizontal slices that you have. And then T, the 4th dimension, is the number of time points. So remember, you're tracking brain function during activity, and so it's going to be looking at that over a series of time points. So one thing I noted at the bottom here is talking about transposing the data. So in terms of data manipulation in lesson 1, the first thing we're going to be talking about is transposing the data. And this basically, so when you're working with fMRI data, it's actually more convenient for the data to be in like TZYX format rather than XYZT for analysis. And this is just kind of like a nuance of working with fMRI data. You don't have to worry about it too much. But basically, transposing the data is a really important pre-processing step. And so it's really simple. All you have to do is implement a method. You can do like .transpose or .t, and it'll just turn whatever array you give it. So if it's an XYZT, after you apply the method, it'll give it to you in the reverse shape, so in TZYX. So this is something that we'll kind of look into in the lesson. Okay, so just as a summary, remember that fMRI data is measured from bold signal, so it typically has 4 dimensions, 3D space plus time, and it can be in many forms, usually in DICOM or NIFTI file format, and then the fMRI data can be loaded using the NIBabble package, which has been kind of made by scientists and researchers for manipulating and working with brain imaging data. So really nice that they did it for us. And then what's next is basically completing that lesson 1 Google Colab assignment and watching the videos and completing the assignments for lesson 2, which is working with an experimental fMRI data set. So I'm kind of going to do a little overview here of the lesson 1 Colab. So this is kind of what it looks like. As you can see here, there's this importing the NIBabble package again. And you'll kind of just go through, if you don't know how to use Google Colab, I kind of said here, basically you just have to run cells, you just press shift and then enter or return. And that's kind of how you just move through these cells and it'll run. And so you'll kind of go through this in places where you see this green text. Hopefully you guys can make your own or apply the methods that I talked about in the previous text, and then kind of see the result that you're hoping to see. So just fill in your code. It shouldn't be more than like this one line, and or if at all, like just copy and pasting what I tell you to apply. if you aren't familiar with Python. Otherwise, if you are, like I said before, feel free to explore the many other methods available for looking into the fMRI data, and kind of feel free to add cells, play around with this as you want, and explore this to a deeper level. But we wanted to make sure that this was accessible and making sense for everyone. And this last part in this lesson is just about transposing the data, like I mentioned before. So there's something called the dot transpose method, and then also just the dot t method. So you can use either of these, and I'll give you a chance to work with both of those here. But in the future, just remember these methods, not only the transpose, but also looking at things like caching the array data, and also looking at the header or looking at the shape. These are all important methods that you want to remember for future lessons. So that's kind of what this lesson looks like. Let us know if you have any questions, and thanks for watching.